So y equals absolute value of x. Okay. If you need to find the bars, they can be found, I think, in a Chromebook underneath the backspace key. So underneath the backspace key in your Chromebook, you can find your absolute value expressions. Okay, and you need to find, you need to find that because you have to put the expressions on your Chromebook. It's okay, LaTroyce, we will be recording on our notebook. So if you could just watch the Desmos screen, you'll be fine. Yeah? Okay, so on your notebook, are you guys ready? On your notebook, you have to have a page that has 4 boxes like this. Well, they don't have to be colored, but what I mean is make 4 boxes on a page of your notebook. And this is where we will be recording. All right, so when you type it in, hi Giselle, good morning. Hi Jessica and Aiden. Okay, so when you type it in, okay, give me 1 second. Let me see. All right, Giselle, I'm on your screen. May I write on your screen? Okay, don't use the 1, honey. I'm gonna do delete, okay? So you will enter, there's like a vertical line underneath backspace. There you go. So absolute value of x. That's the one. Okay. So for those who are done with their graph, can you please label your 4 boxes like this? I'm going to share the boxes you will copy. There you go. While I help the others on Desmos. Can I have the link for the Desmos, please? Here you go, honey. All right. So if you're kind of lost, I'm just making your classmates copy the 4 boxes on their notebook. Okay. All right. So the function I made you graph right now is called the absolute value function. Okay, and the parent function, meaning the original function, is written as y is equal to absolute value of x. Okay, so that's how you read it. So let's try to sketch the graph that you saw on Desmos. So if you make, am I sharing this? Do you see my writing? I'm making an x and y axis. Okay, there you go. So make a V graph starting from the origin. There you go. That's supposed to be straight. All right. So make a V graph starting from the origin. You call this origin your vertex. Am I going too fast? Okay, let me pull up the chat on my Chromebook so I can see you message me. Because right now, okay, my laptop is using the Desmos and the graphic organizer. Okay, so the vertex is actually your turning point. Now, what do I mean by turning point? It's called the turning point because it's the point where the graph switches direction. So from the left side going to the middle, it's actually decreasing, right? Because it's going down. And then from the middle to the right, it's actually increasing. Good morning, Sophia. We're kind of looking at 2 screens right now, honey. So this is the Desmos. But if you cannot make the Desmos work, don't worry, because I'm recording the important ones on the notebook. So make sure that you guys have your notebook. All right. Now, since we started with the graph by using decimals, I still want you to learn how to do it by hand. So let's make a table of values by hand. Here we go. X and Y. And the minimum number of ordered pairs to make the graph is 3. So minimum of 3 coordinates. The middle one is called your vertex. Well, not necessarily the middle, because if you want to get it first before the other points, then that's fine. But normally the vertex is in the middle, or it's the turning point. So the vertex is, oh, where's my pen? Okay, here we go. Ooh, it came out from the wrong spot. Okay. All right. So the vertex is 0, 0. This is only for the parent function, okay? Is it always 0, 0? No. Later on, I'll show you something that doesn't have a 0, 0 vertex. Okay, now once you have the vertex, you could just get 1 point from the left and 1 point on the right. So let's use -1 and +1. Now, do I have to use -1 and +1 all the time? Well, no. I mean, it's up to you. It's your choice. But if you just want to get the shape of the graph, then you can just have 1 point on the left and 1 point on the right. And normally, the lesser the values you substitute, the smaller values you substitute, the better to, the faster it will be for you to simplify it. So I would just say -1 and +1, right? Okay, so if you get the y is equal to the absolute value of -1. So that means it becomes +1, right? So the absolute value of -1 is actually 1. Why? Because it's 1 unit away from 0. So when you say absolute value, it's how far away, okay, so how far away the number is from 0. So that's what we mean by absolute value, okay? So if you want to get the absolute value of 1, it's just 1 to the right of 0, so the answer is also 1. So that means the y value here, 1, and that's where you can find your points 1, 1, and -1, 1. So that means for 2 different values of x, you get 1 value for y. Okay, I'm going to pause right here, and it will give you some time for questions. Just making sure I did not lose anybody. Do you have questions so far? None? Okay. Now let's write down the properties of the parent function. So, number 1 property, the vertex is 0, 0. Right? Number 2, since if you fold along the y-axis, the left-hand side would match the right-hand side, then you would say the graph is symmetric. Symmetric. Okay? It's symmetric because the y-axis splits it evenly into half, right? So number 3, now I label these ones as decreasing and increasing, right? So that means the graph decreases when, so when is it decreasing? It's decreasing to the left of 0, right? So that means when x is less than 0, it's decreasing. On the other hand, the graph increases when x is greater than 0. So why is that? Well, because to the right of 0, the graph is going up. Okay? Number 5, the domain is all real numbers. So when I ask you what's the domain of any absolute value function, it's going to be, all real numbers all the time. Okay. And then number 6, last one, the range is, okay, so what's the range? The range here, the lowest y value, meaning the deepest portion of your graph is at the vertex, right? So the y value there is 0. So that means the y values used in the graph are from 0 to positive infinity. So you put the range is y greater than or equal to 0. The range is y greater than or equal to 0. Okay. So that concludes our graphic organizer. So copy that down. Let me know when you're done. And I will switch back to the decimals. Okay, I do not normally discuss these properties in my regular classes. So you guys are the only ones I discuss this with, because when you go to Algebra 2, you will be needing this. When you take AP Pre-Calc, you will be needing intervals where it's decreasing, where it's increasing. So I don't normally go as detailed as I do right now with you. So please write this down. You'll never know when you're going to need them, you know. Okay, let's move on. I'm going to switch back to my decimals and go to slide number 2. Okay. Yeah, all the screens are blank. So, yeah, they just have their titles, but I will direct you how you're going to do them. Okay, so in number 2, we need to find the vertex. We need to find the vertex. So how are we going to do the vertex? All right, here we go. I'm going to borrow, Joshua, I'm going to borrow yours, right? Thank you. Okay, so I'm using Joshua's screen right now. Our goal here is to discover where to find the vertex. So go ahead and type in your original function again. Y absolute value of x. There you go. I'm going to zoom out so we can see Joshua's graph. Okay. Now, how do we move the vertex of an absolute value anywhere else on the screen? Okay. By moving it to the right or left. Well, you're going to think of a number. So let's see. I'm going to start with adding 1. Add 1. So plus 1 inside your absolute value. I'm going to zoom in so we can see where Joshua's graph moved. Okay. You guys follow this? So when I added 1 inside the absolute value symbol, where did the graph move? Can somebody tell me? In the chat or orally? It would be nice if you just unmute yourself, because so you don't have to switch from, I don't know, whichever is more convenient for you. So can you tell me where the graph moved when I added 1 to x? Anybody? Somebody tell me where the graph moved when I added 1 to x. It moved left. Very good. To the left. How many times? I need to know how many times. 1 to the left. I love it. I love it. Okay, good. Now, go outside the absolute value expression. Go outside. See, my cursor is outside. You see it's blinking outside the bar? Now, you're going to add 1. You're going to add 1. Can you tell me what happened now to the graph? Can you tell me what happened now to the graph? So after moving left 1, where did it go? Up 1. Very good, Giselle. Up 1. Very good, Dwight. Awesome. Okay. So where is now the new vertex of your graph? So where's the new vertex? Can you tell me? Where's the new vertex? What are the two numbers for the vertex? It's no longer 0, 0. What are they? When you say 1 to the left, that means what? Where is the number here? What's the number right here? Right here. -1. Very good. +1. Good job. See, you discovered where the vertex is. Nice. Okay. Well, go ahead and change it. Change your +1 to +2. And then change your +1 to +2 again. Where did the vertex go now? Where did the vertex go now? Awesome. Okay. Now maybe you're wondering if it will ever go to the right. Okay. So then instead of +2, go ahead and change the plus to minus. Change the plus to minus. Ooh. What happened now? Can you tell me where the vertex went? Well, this is so nice, in the classroom when you guys can really describe what's happening. Oh, I miss it. Okay. All right. So the vertex now, according to Brian, is at 2, +2. Very good. Okay. Maybe you're wondering if it will ever go down. So you want to change it to -2 now? Ooh. What happened to your graph? Where's your vertex? Where's your vertex? Where's your vertex now? 2. Okay, Chris said 2, -2. That's awesome. 2, -2. And Brian also said 2, -2. Okay, so based on what you've seen so far, can you tell me how to find the vertex? Tell me how to find the vertex. What pattern did you see? Tell me how to find the vertex even without actually seeing the graph. So if you see an equation like this, how do you find the vertex in the equation? I know you have something to say, you just don't know how to explain it. So type in the chat how you want to say it, and we'll fix it for you. Don't overthink. Come on, just tell me what you think in the chat, and we'll take care of the rest. I would love it. In the classroom, you will be, no, it's like this. No, it went like this. Oh my God, I missed that. Okay, so tell me what you think. How do you find the vertex? What's the pattern that you guys saw? I'm sure you have an idea. Come on. Tell me. Anybody? So to find the vertex, do you see my screen now? So to find the vertex, if you have y is equal to absolute value of x, let's say minus whatever number you have, I'm going to call it k, all right, plus k. What do you do with the number from the inside? What do you do in the number that comes with x or that goes with x? Let's say in Sophia's graph, so the +2, it became -2. So what's happening, right? So look at Sophia's graph here. So if this is positive, okay, it became -2 and 2. Ooh, look, do you also get the opposite of the one outside? What do you think? Hi, Nyla. It's okay, Nyla. Just focus on the screen right now, honey. Don't overload your device because I don't want you to be logged out. It's okay, honey. Okay. Okay, so what's the pattern? I hate to give the answer to you, but okay, so this number, right? You get the opposite of that one. So in Sophia's screen, if this is +2, the vertex from here is -2. You see where it went? That's -2, right? But the value of k outside the parentheses, you copy it exactly. So this is -2. That's your vertex. So -2, -2. You see that one? -2, -2. Okay? All right. So you only do the opposite if it's coming inside. Well, why is that? Well, because if you have x plus 2, and you want to get the x value that makes it 0, it's actually negative 2 plus 2 is equal to 0. So it's the opposite, right? Okay. So on your notebook, can you copy this down? On your notebook, can you copy this down? Let me close out this one. Yeah. So on your notebook, okay, copy what I'm going to write. Okay. If y is equal to absolute value of x minus h plus k is graphed. Copy this down on your notebook. I don't have space, so I'm just putting it here. If y is equal to x minus h plus k is graphed, the vertex is hk. H, comma, k. So what does that mean? This one is the opposite because it went to the opposite direction, right? And then this one is you copy it exactly. Okay. All right. Very good. Okay, that's the first thing I want you to learn today from Desmos. Did you copy that down? Okay, we're going to move on. Here we go. Clear ink. Next, slide 3. Slide 3, I'm going to use Vincent because he was here first. I saw his slide first. Okay, here we go. Vertical transformations. Vertical transformations. So type y equals absolute value of x again, right? Okay, so now I want you to write an equation that moves the graph 5 units up. I want you to write an equation that moves the graph 5 units up. So what will you do to your function? What will we type after absolute value of x? Go ahead, Vincent, you can edit it. Plus 5, according to Brian. Very good. Plus 5. Okay, so let me zoom out so you can see it. Very good. Y minus 5. Yeah, you can also do that. If you put the y minus 5 over here, that's fine because when you move it to the right, Vincent, it will go positive 5. Yeah, that's fine. Okay, so now how about make another graph that moves your original function 5 units lower. 5 units lower or 5 units down. So what are you going to do? What will you put here? So you can move. Very good, Giselle. So minus 5. Good job. So what conclusion can you make over here? What patterns do you see here? So when does the vertical transformation happen? Yes, Vincent, that's also okay. So if you do y plus 5 is equal to absolute value of x, it would give you the same graph. You see it? Right? It ended up on the same graph. The reason for that is because when you add the 5 or when you move the 5 to the right hand side, it will become negative. So that's also correct. All right. Okay. So when does the vertical transformation happen? You have to know where you're adding or subtracting the numbers, okay? So if you're adding or subtracting it outside the absolute value bar, then it will become a vertical transformation, and we will summarize that later on. So I hope you're just watching your screen at the minimum. Don't worry about writing them down because we will summarize them later on our notebook. Okay, I'm gonna move on to the next. This time, let me borrow someone else's. Move on to number 4. And the first one I see is, nope, nobody's yet ready. Can somebody click on the graph? Oh, there you go, Jaylene. Hi, Jaylene. Awesome. Go ahead, Jaylene. Type in your absolute value for me, please.
I didn't understand that.
Sorry, Bixby. I'll teach you more math. Okay, so y equals absolute value of x. Yeah? Okay, now I need you to show me a graph that's moving 5 to the right. 5 to the right. So what are you going to do? X minus 5, Brian said. Very good. But this time you're putting it inside, right? Inside the absolute value bar. And if you put it inside, okay, the result is to the opposite direction. That's nice, Brian. Okay, then go ahead and show me a graph that's moving 5 to the left. Show me a graph that moved 5 to the left. How are you going to type that? Awesome. So that's going to be x plus 5. So the only thing I wanted you to see here is if you're adding or subtracting a number inside the absolute value bar, you're changing it horizontally to the opposite direction. Okay? So we'll summarize that later on. Let's keep going. I think we have 3 more. Okay? Now, let's start again with our original function. Did I lose anybody? Am I going too fast? You don't worry about writing this down because I'll show you how to write faster and easier later on. Just watch the screen and try your Desmos. That's all I'm asking right now. So y is equal to absolute value of x. Okay, now find a way to flip the graph over the x-axis. So give me a graph that's facing downward. Oh, I'm sorry, Jaylene. I keep using yours. Sorry. Okay. So we are in slide 5 now. Give me a graph that's now flipped downward. Hi, Giselle. May I use your screen? So y is absolute value of x. There you go. Okay. So now what will you do to flip it down? What will you do to flip it down? Okay, so Jessica suggested put a negative outside. Let's do that. All right. And then Alyssa also put a negative. Yes, so put a negative on the y. So if I do negative y equals absolute value of x, that will be the same thing, right? Alyssa? It has the same effect, but we just wanted to get the y by itself, honey. So I put it on the right-hand side. Did that make sense? Okay, good, good, good. Awesome, you guys. All right. Okay, so let me delete the negative. Or let me delete this one. Okay, so when you reflect it across the x-axis, you have to put a negative, what do you call this? You have to put a negative outside the absolute value bar. Okay. All right. Now, what will happen if you put the negative inside? Y equals absolute value of negative x. What's going to happen? It didn't flip downward, right? But it flipped across the y-axis. So you see, this is like the original, but it flipped across the y-axis. So if the negative is inside, you reflect it across the y-axis. Okay. Let's move on. Those are our types of reflections. Thanks, Giselle, for letting me use yours. Next, 6. Ooh, here we go. Hi, Ryan. I'm going to borrow yours, yeah? So, Ryan, vertical compression and stretch. Ooh. In other words, how do you make it closer to the y-axis or farther from the y-axis? Or how do you make it wider and narrower, in other words? Okay. How do you make it wider or narrower? Any idea? So what else haven't we done yet? So try to put a number over here. Try to put y equals, I'm going to separate them so you would see what happens. Ooh, look at that. Yeah. Okay. Go with your teacher, honey. Okay, so look when we multiplied. Are you done, Sumi? Okay, so look at when we multiplied by 2. What happened? Did it become wider or narrower? Okay. 2 absolute value of x. Oh, where did I put it? My bad. You're right. I put it in the wrong spot, honey. Thanks for catching that. Yeah. I meant to show that later on in the last slide. Thank you, Brian. Uh-huh. So if you multiply the 2 outside, okay, it's vertical, right? And remember when we were adding numbers and subtracting numbers outside, it was also vertical movement. So that means everything that you do outside the absolute value bars will have vertical effects. Okay, like this one, it became closer to the y-axis, so that's a vertical compression. How do you make it wider? How do you make it wider? So let's say y equals absolute value of, to make it wider, substitute, let's say, a fraction. See the blue one? We don't see a fraction, but it's a decimal, right? 0.5. Okay. Ooh, my other device got disconnected. Okay. Yeah. So that means I have to open the chat over here. All right. So zero point 0.5. Very good, Alyssa. So if you use a number that's less than 1, okay, then it will become a vertical stretch. We call it stretch because it's stretched away from the y. Okay. So can the fraction you put there though be negative? Experiment. Look, if you put a negative, what's going to happen? What's going to happen? So if you put the negative with a 0.5, the graph became wider, and at the same time it flipped around the y-axis. Okay. But if you put the negative outside, there you go. It became wider, and at the same time it flipped over the x-axis. All right. Okay, but let's just go back to the original. Okie dokie. And one last, and then we'll summarize everything we saw. Okay, on the last one, number 7, horizontal. Anybody in here yet? If you got stuck in decimals, that's okay. I'm recording this so you can follow along later on. I already anticipated that because it usually happens when we use decimals. So I recorded everything. I'll upload it later. Okay, so now for horizontal, this time you're gonna put the values inside or in between the absolute value bars. So let's say on Alyssa's, I put, there you go. I put the 2 inside. Yeah? Okay. So did it move closer or farther from x? Or maybe I should separate it so you can see the difference. Y is equal to absolute value of 2x. Okay. All right. So earlier, when you multiply outside, it moved the graph closer to the y-axis. But this time we're looking at horizontal. Horizontal. Okay? All right. So the absolute value of 2x now is, what happened? How do we change this color? Do you know how? How do I change? Oh, that's cool. If I make this green, hold down on it. Yeah, I just discovered that, Jessica. Thank you. I know. I did not. Okay, here we go. All right. So this time, if you multiply it to 2, okay, it didn't go closer to x. It did the opposite direction again. It went farther from x, right? Yeah, so horizontally, um, that's actually, what do you call this? It was actually stretch away from x. Okay, if you make that, let's say y equals absolute value of 0.5 x, absolute value. Okay, see what's going to happen? The lower the value is, it's closer to the x-axis. Okay? All right. So earlier it was the other way around. If the 2 was outside, it was closer to y. But now, if the number 2 is inside the absolute value bars, it's farther from the x. Okay, so I hope that you realize that anything we do inside the absolute value bars always have the opposite effects. It moves to the left if it's plus, it moves to the right when it's minus. Okay? All right, and then if the number is bigger than 1, it's being compressed. Okay? And then if the number is smaller than 1, then it's stretched. Okay. All right, now we're going to summarize everything we saw. Go back to your notebook, clear ink. I should have another one. Here we go. I hope I'll have enough space to write everything down. So write this down on your notebook and we'll summarize what we did. Did I miss anything in the chat? Let me know. Okay. All right. So if it's plus k, so what do we put? I'll just write down the keywords, okay? So this will be vertical translation because it moved up, right? K up. Then this one, same thing, vertical translation, K down. All right. Will you go back to the slide and decimals because I came to this class late? Will you go back to the first slide? Oh yeah, sure. Okay. Now I'm mental blank again. So what do I do again? Decimals? Okay. I don't know. I do this every day, but sometimes I forget how to do it. That's crazy, huh? Okay, so in the first slide, I just did y is equal to absolute value of x. Nothing else. Only that. Okay? All right. I don't know which one you needed, honey. Let me know. But that was the only thing we did. Okay. All right. Now let me go back. And how do I go back again? Concept map. Okay. Next, this one is your horizontals. So horizontal translation. H to the left. Okay, so here for the vertical, you follow the sign. Okay, for vertical, you follow the sign. But for horizontal, you go to the opposite direction. Okay, opposite direction. Sometimes this memorizing these will be enough. Like if it's vertical, you follow the sign. If it's horizontal, you go to the opposite direction. That's faster than memorizing them one by one. Okay, so you have to find a way to like make it easier for you to memorize. So H to the right, and I'm just keeping it real. If there's one thing from Algebra 1 that you must not forget, it's this lesson because it's going to be used all the way to Algebra 2 and Pre-Calc. So forget everything but this. Okay? Next one. This is reflection across x-axis. All right? Next one. Reflection across y-axis. Okay. Next, if A is greater than 1, okay, then it's a vertical stretch. Okay, vertical stretch. In AP, they say by a factor of A. Okay, so in AP, in AP Calc, they don't just say it's a vertical stretch of the original graph, but you have to say by what factor. So meaning you're going to say what letter A was multiplied, okay? So vertical stretch by a factor of A. But if it's a fraction or a decimal between 0 and 1, okay, then it's a vertical compression. Some students says vertical shrink, but I don't want you to memorize that. Okay, higher math calls it vertical compression by a factor of A again. All right. So anything that's done outside the bars, they follow the same exact thing. They follow the sign, or if it's bigger than 1, you stretch it. If it's smaller than 1, you compress it. Okay, this is horizontal, so it's going to be the opposite. If B is bigger than 1, okay, it's going to be horizontal. Now I said it's the opposite, so don't say stretch. You got to flip them around. This time it's going to be horizontal compression by a factor of, since we're flipping it, we're also going to flip the value. So if it's B, we're going to say 1 over B. 1 over B. So if it's 2x, then you're going to say 1 half. Okay? I will illustrate that to you once you get to the graph. So for now, just record them, okay? Oh, this should have been an A. Why did I put a 0? A is between 0 and 1. Can you check this one? I put 0. And then if B is between 0 and 1, meaning it's a decimal, horizontal stretch by a factor of B. So what does that mean? If they give you 1 half, then you have to switch 1 half and make it 2. Okay? So normally, the easiest way to memorize this is you use the reciprocal. Use the reciprocal. Okay. So the only things you need for your homework today are this table and, oh yeah, that's it. This is the only one. I'll show you how to do your homework. It's easy. Okay. Every year it's a student's favorite topic for some reason. I don't know why. Okay, are you done copying? Okay, I'm gonna switch. If you miss anything, I will be uploading the recording right after. So can you go to this one, 3.7, graphing absolute value functions, so I can illustrate to you how to do it so you don't get stuck. Okay. I would say do this in Cami, right? The choice, you've done it already? Okay. But there might be some missing parts in it. So can you um, make sure everything is in there? I gave you the website to check your own answers. Okay. But what I'm going to be asking from you must be written on the PDF. So how? So let's say, for example, the first thing I'm going to ask from you is to make a table of values. The website doesn't show you this. You have to come up with this. X and then Y. You have to give 3 all the time. And how do you get this 3? The middle one is always your vertex. So today I taught you how to find the vertex, right? Okay, you get these 2 numbers, you write the opposite of that one, and then you copy the external number, right? So what will be the vertex of number 1? And you can double check your answer because I gave you the website, but I need to see your work and I'm modeling to you how you're going to show your work. Okay, so what is the vertex here? Somebody tell me in the chat. What's the opposite of -2? +2, right? Are you guys watching this? Am I sharing this? Okay, 2, 4, 4. Chris, we only do the opposite of what's inside, but the one outside. Very good, Jaylene. You copy it down exactly as it is, okay? I know that's a common mistake, honey. That's why I'm emphasizing it. And that's why I showed you in decimals so you can see. If you're not sure, I also taught you how to do it in decimals, right? So you have this website right here to check your answers, but the table don't show, just the graph. And I also taught you how to do decimals. Okay? So if you're confused, you have 2 ways to check. But if you memorize it, it's the opposite of that number, and then you copy this down. So -2 means 2 to the left. I'm sorry. It's +2, so 1, 2 to the right, and then 4 down. 1, 2, 3, 4. So this is your vertex. And then after the vertex, okay, you use the numbers immediately to the right and to the left. Let me say that again. Use numbers either immediately to the left or to the right. Okay? So I'm going to use 1 and I'm going to use 3. Okay. So now, how do we get the y value? You're going to substitute it. If x is 1, what is 1 minus 2? 1 minus 2 is -1 minus 4. Now, what's the absolute value of -1? It's going to be 1. So 1 minus 4 equals -3. So the partner of 1 is -3. This one Desmos won't teach you. It will show you but not teach you. So you try to watch and understand this one. And the website doesn't give you this either. Okay. Next, use 3. So watch again. If I use 3, 3 minus 2 is 1. So the absolute value of 1 is 1. And then I subtract 4. What do I get? I get -3. Okay, how do you know that you're not messing up? Should the numbers match? Okay, so when x is 1, you go to -3. When x is 3, you go to -3. Okay? So if they don't match, if you don't make a V pattern, then you know you're wrong. Oh my god, I did not hit the dot. Okay. So that's how you figure out whether you're messing up your tables or not. They should make a V pattern. Okay. All right. Now what if there's no number outside? Let's look at number 2. So make sure you show this on your assignment or homework. If you only show me the graph, I have the graph. I have the graph on the website. So I want you to give me this so I can see what your vertex is and how you got the points. Did you guys understand? Yes or no? I don't want you asking me, why did I get a 0? If you just give me the graph, I'm going to give you a 0. I even give you the website for the graph, right? Okay, good. All right. And then after that, you have to describe the transformation. Let's say -2. Remember, how do you use the concept map? If there's something subtracted inside, what do you put? Horizontal translation, h to the right. So you have to put that, right? So -2 means horizontal translation to the right. This is going to be our homework. Yes, honey, only this page. This paper. Yeah, there's 2 pages. And then the -4, you also have to explain It's vertical translation for down. I'm okay with that. 4D, 4 down. Okay? Yeah. But please write it out. So down, right. Okay. And quickly, before you log out, if there's no number outside, imagine there's just a 0 over there. So that means your vertex here will be -1, comma 0, right? So when you make your table, x, y, that means x is -1 because you get the opposite, but there's no number outside, so it will be 0. Okay? And same is true here. If there's no number inside, then that means the other number there is 0. Okay? All right. So I just want to make it clear. Don't just graph. You just give me the graph, I'll give you a 0. You have to write the table of values and you have to explain the transformation. All right. How was that? And tomorrow, if you need any help, I am staying again. I think I'll have about 15 minutes after school tomorrow, after my last period 6. So message me so I can send you the Zoom link if you need help. Okay. All right. So if you have no more questions, feel free to log out. If you have a quick question, you may stay behind if you want to. I have probably 3 minutes before. Okay, we log out and prepare for the next class. Bye, Jessica. Have a great one, honey. It's okay. Okay, thanks, Alyssa. On how to find the bottom and top numbers of the graph. Bye. Bottom and top number. Okay, can you be more specific, honey? Like this one? The vertex? Is that what you mean? Oh, other than the vertex. I get it. So once you find the vertex, right? This one, the x value will be the number immediately to the left and to the right. So for example, if the vertex is 2, right? The one to the left is 1, and then the number to the right is 3. Okay? So now what do you do with those two numbers? Where's my pen? So once I've found those two numbers on the left and on the right, I substitute them in the function x minus 2 minus 4. So for example, since the number on the left is 1, I go y equals 1 minus 2 minus 4, right? What is 1 minus 2? 1 minus 2 is -1. Then, what's the absolute value of -1? It's just 1. So 1 minus 4 is 3. That's how I got a -3, sorry. So that's how I got the -3 over here. Okay? And, most of the time, the other number is the same. That's how you get the V pattern. But I still, you should double check. So that means when you substitute the other number, hang on, honey. Mommy's helping somebody. Mommy's helping my student. Oh, perfect. Very good. So the other number here on the right was 3. Yeah. So you go y equals 3 minus 2 minus 4. Well, what is 3 minus 2? That's 1. What's the absolute value of 1? 1. And then minus 4, so that's -3 also. All right? Did that help you, Denise? Hopefully. Okay. All right. Anybody else? You guys have a question? Hi, Dwight. Do you need help, honey? Oh, okay. I don't know. He didn't respond. You're good? Okay. Bye, Dwight.